Well, thank you everyone for joining us today. My name is Max Yartzberg. I'm the co-managing director of Park County Environmental Council here in Livingston. PCEC is your local community organization. We work to protect the lands, water, wildlife, and people of Yellowstone's Northern Gateway. Um, I just thought I'd quickly take care of a little bit of housekeeping before we jump into it. The presentation, as you noticed, is being recorded so we can share it with people who are unable to join us at this hour to listen in. We've got some staff and some membership up in Helena right now for the Public Lands Rally that's taking place at the Capitol this very minute. So they may want to check this out later. We're glad they're up there supporting our public lands and showing up for that. In the meantime, if everyone can just stay on mute during the presentation to minimize any disruption, that would be really appreciated. We are going to set aside some time at the end for some Q&A and some discussion. So if you could hold off with questions and whatnot until that time, that would be great. If at that time you can come off mute, turn on your video, whatnot, ask questions, or you can also just drop questions and comments into the chat window as well. So that's all the housekeeping I have for you. We're gonna try to get this all in an hour. So we'll get started. It's a good week. We picked a good week to do a presentation on snow, I think. I mean, look at all of it piled up outside. I haven't seen a snowstorm this long and this deep in Park County since I was a kid. It's pretty remarkable. I love it. It's unless you get stuck in it, it's quite a lot of fun to go out and play in it. There are so many reasons to track our area's snowpack and the snowfall. If you're like me, it's because you love skiing and you want to know the latest conditions and what the avalanche risk might be so you can stay safe in the mountains. Or perhaps you're a producer and drought is always on your mind and it's always a day away and you want to keep track of our snowpack to know what our spring and summers are going to be. And the same for our wildland firefighters. I mean, our snowpack is really critical, moisture reservoir for us in the mountains and can sometimes determine how severe our firefighting season is going to be. Yeah, the snowpack is our cold water reserve. It's what fills our creeks and rivers every spring and summer. And on that note, looking at all the snow piling up, I can't help but thinking about what our snowpack means to the risk of flooding. And so it's just so critical to know how much snow is out there, how much water is stored in our mountains. And when it begins to melt out, it can really, we really have to, use this data to prepare. The snow science and snow data that we have that Eric's going to present on is just provides so much invaluable information for everyone in this community. And it underpins so many decisions and inflection points that we have to make throughout the year when we plan activities or manage our businesses. And this science and this data collection largely goes on in the background. It's not, it's tucked away, as Eric will say, it's tucked away. Everything is up, up in the mountains, and so we don't really see it. And that's why I'm excited to have Eric Larson here with us today to do a deep dive into snow science and his work in that area and to talk about Park County's snowpack. First, a little bit about Eric. Eric serves as the snow program manager and hydrologist for the USDA NRCS Montana Snow Survey Program. Over the last 11 years, he has specialized in maintaining and installing snowpack measuring stations, also known as SNOWTEL, across the mountains of Montana and northern Wyoming. When he's not in the field, Eric analyzes snowpack and water supply data, translating complex information into accessible insights for a wide-ranging audience. Outside of work, Eric enjoys embracing Montana's outdoor wonders. In the winter, he and his wife Alicia and their dog Indy spend time skiing. During the summer, they can often be found exploring Montana's rivers. home to the water Eric measured throughout the snowy season. So without any further ado, I'd like to turn this over to Eric in your presentation. So take it away, Eric.
All right. Thank you, Max, for the introduction. Really appreciate that. Let me share my screen here.
I think you're all up and going with
It's
this
all good to
share.
go already?
Yeah.
Okay. Perfect. All right. So yeah, thanks again for the intro. Yep, as Max said, I'm Eric and Park County resident since about 2015. Lived in Montana since about 2002 when I moved out here to go to Montana State University for college, and been working for the snow survey program since about 2013. And prior to that, I worked for the NRCS, USDA NRCS for a few years prior to that, working as an engineer. But during my tenure here in the snow program, I spent quite a bit of time trying to, or just deciphering snowpack data, precipitation data, what that means for runoff, all the fun stuff, whether it's for water supply or whether it's for recreation. So I hope to pass off some of that information to you folks today. And I do have an outline for this presentation on the next slide. So let me do this here quick. Do a pointer. There we go. Okay, so yeah, but before I go to that outline, I just wanted a little note on the pictures. So as Max mentioned, the region I cover and my staff and the rest of us cover is all of Montana, the Black Hills of South Dakota, and northern Wyoming. So a lot of the pictures or photos we took just throughout the rest of the state. I did try to focus a lot of the data related points in this presentation on Park County in particular, so we can learn a little bit about what the snowpack is looking like this year in Park County as well. Okay, so presentation outline. So it's kind of broken down into two parts here. First part being the critical role, the importance of snow as it relates to water supply, stream flow, drought, and just a couple other general little things of why snow is important. And then the bulk of this presentation is going to be decoding the snowpack data. There's just like so much information out there. It can be a little hard to find what you're looking for. So hopefully, like I said, pass on some of that information to you as well. And just related to a little background on the program, data access, how to interpret it, a few resources for both recreation and just general non-NRCS related snowpack sources for you. Okay, so kicking it off with this first part, the critical role of snow. This photo, some of the snow survey crew took this last August in Glacier National Park, uh, August 2024, and they're just doing work on the Flat Top Mountain Snowtell, which you'll learn more about snowtells later in the presentation. But I just thought it was classic Montana weather, just snowing in late August. So. All right. Spring and summer stream flow. And so what comprises spring and summer stream flow? I mean, you've all seen it. Low snow years generally result in a low river levels throughout the summer, particularly later in the summer. But it's not all about the snowpack. There's other factors that play into how much water we have, what drought is looking like. Some of the other big indicators are spring precipitation. I have a couple examples later where we actually had a pretty low snowpack year, but spring and summer precipitation was able to kind of bump those river levels up a little bit. And then soil moisture as well, just monitoring how much water is stored in the soil. The snow survey program measures all three of these at snowtell sites. Not every snowtell has soil moisture, but a bunch of them do. But all snowtells measure the snowpack and precipitation. All right, so what I broke down here are some examples of monthly median precipitation totals. So we're looking at the 91 to 2020 median for three different snowtell sites in the Upper Yellowstone Basin. So Fisher Creek Snowtell, Parker Peak, Ocean Plateau. So total annual precipitation at each of those, it ranges from about 30 to 50 inches of total annual precipitation. And so we got our months right here, inches of precipitation. So you can see during these winter months, October through May, significantly more precipitation is typically or normally received. So what I did there was just divided assuming it's snowing in October through April, 37 divided by 51.8 is about that 70%. So that's kind of where that 50 to 80% number was coming from earlier. And then just to point out how little precipitation some of these mountain snowtell sites receive for that May through September time period. This chart was created by the Montana DNRC in 2015 as a part of their state water plan. So it's just showing water consumed in Montana. And down on the bottom here, agricultural irrigation, by far the largest component of our water consumption in Montana. And part of the reason that the snow survey program that I work for exists under the USDA. So we're essentially monitoring the snowpack to know how much water we're going to have for irrigation. Okay, so the relationship between snowpack and drought. So I'll be the first to say I'm not like an expert on drought. My expertise is more within the snowpack. There are the drought management team and designation crew that does their weekly designations for, as shown on the right there. They're kind of looking at the bigger picture. My contributions are generally just related to the snowpack. But what I do know is the snowpack component. So tell you a little bit about that. The snowpack is thought of as like a mountain reservoir accumulating through the winter and hopefully melting a significant amount of water into our waterways throughout the drier summer months. There's essentially maybe two types of snow drought. You can think of the situation where it's just not snowing at all. So just lack of precipitation throughout the winter. You might be dealing with snow drought. There's also the case when it is precipitating, but it's actually too warm to snow. So that might be occurring more on the tail ends of the season. October, maybe it's raining rather than snowing. So just kind of factoring in those two types of droughts and frozen soils. So in the winter, typically, the snow is sitting there, it's not melting, soils are frozen. So it's more when you're considering the snowpack and determining drought, you're more looking at like what that might provide in the spring and summer runoff season and the timing and drought designations related to that. They're not gonna, like, say you went into the fall with like really exceptionally dry drought conditions, but then you had a pretty good winter. The drought team is keeping up with those designations based off what the snowpack is doing, because they don't want to jump from like a D4 to like a D0 when the snow starts melting in the spring. So even though, if it's low snow year, we might not be experiencing those effects in terms of dryness of our soils and whatnot throughout the winter. They're just planning for the summer, essentially. And then, of course, there's other factors: soil moisture, temperature, and precipitation. So, a lot of evaporation, evapotranspiration with like really hot, dry days could add to snowpack or overall drought conditions. So then I got a few example drought years here. So a little disclaimer: this is historical drought conditions across the entire state. So, the snowpack varies across the state. You could be pretty decent snowpack in the Northwest and very dry elsewhere, vice versa. But this is just kind of showing some of our biggest statewide drought years. So we're looking at this 2004 to 2005 right here. And then just quick summary of what that looked like statewide. Snowpack peaked early, behind normal, like highest snowpack levels in the spring for in terms of peak snowpack. And it was early, above normal precipitation during the summer of 2004, and then near record low snowpack in 2005. So, kind of an example of a year when the drought might have been related to the snowpack because we were getting precipitation during that summer. 2017 is another example. So normal to above normal winter snowpack, mid-May through mid-September were very dry. So record low precipitation at many snow tells during that time. So normal snowpack, but then the summer conditions right here, very, very dry. So, uh, you know, it's not all about the snowpack, but it is a major component. And then 2021, just overall dry years from 21 to 22, below normal snowpack, below normal precipitation. But then in 2022, of course, we started getting precipitation again during that spring, and that helped kind of drop the drought conditions. Other important roles of snow, so albedo, so the reflectance of the snow on the surface of the earth helps cool the earth. This is just showing some different examples of the albedo for like the open ocean, for example. You know, some of that solar radiation is absorbed into the ocean. Bare ice is a little bit more reflective, about 50-50, and then ice with snow. So a lot of that solar radiation that's heating up the earth is reflected off the snow. So if we continue to lose our snowpack over the years, we have potential issues of warming things even more. And wildlife, obvious hibernation, migration patterns. Just snow is important for a lot of different types of wildlife. And then just staying happy with recreation, looking at skiing, and also getting out there fishing. That's Alicia, my wife Alicia there, and our dog Indy fishing on the Yellowstone River. Cool. So decoding the snowpacks. Like I said, this is going to kind of be the bulk of the presentation here. I got a lot of charts and graphs and little information on the background of the snow program. This is the current snow survey staff. We got Florence Miller right there in the front, and then Joe Crawl up at Twin Lakes Snowtell in the Bitterroot Range. Okay, so snow survey and water supply forecasting, also known as SSWSF. We were created in 1935 by Congress in response to the drought and Dust Bowl. However, there were some snow measurements being collected prior to 1935, so we do have some of that in our data set. We're a west-wide program from New Mexico all the way to Alaska. And I mentioned it before, in the West, snow equals water. And then we're congressionally funded discretionary funds. And our main task is we're mandated to provide accurate and reliable water supply forecasts for agricultural use. We measure the snow. A lot of people use it for recreation, all the reasons. But like I said, we're doing this for water supply forecasting. So what do we do at the SSWSF? We measure the snow. We have two types of stations, snow courses and snow tell sites, and I'll get into each of those a little bit more in depth in the next few slides. We also collect data from other agencies and put that in our database. Those are used for our water supply forecasts, which are issued monthly, January through June, or March through June. That time frame kind of depends on where you're forecasting. Forecast hydrologists are based out of our National Water Climate Center, so they're part of our team. We work with them. We do the data collection, they do the forecasting. And then the other big part of our job is just disseminating the data via tools, products, reports, media interviews, that type of stuff. Our two types of data collection locations or stations are snow courses and snow tell sites. So snow courses are the more historic of the two. They're manually measured. We take snow cores with that tube shown there that I'm holding. You basically get a core of snow and weigh it to determine how much water is in it. And you're also measuring the depth at the same time. So I got a map of all the snow courses later on too. But Snowtel sites, Snowtel stands for Snowpack telemetry. They're automated. 1975 is about the time for mid 70s is when Snowtels first started being installed, just due to the technology being available to automate things. There are some records, automated records with like recorder charts prior to the mid 70s. They essentially weren't telemetered like the Snowtel. So they weren't called Snowtel, but there is automated data pre 70s as well. So the way that we quantify snow as a program, kind of our main bread and butter, snow water equivalent, SWE. So if you took a column of snow, melted it down into, it would result in inches of water. That would be your snow water equivalent. We also measure the settled snow depth, just sitting on the ground. And then from those two, snow water equivalent divided by snow depth, you can get snow density. And so you might have heard before, 1 inch of precipitation might equal about 10 inches or 1 foot of snowfall, snow depth. That would be 10% density, which is pretty typical. Or say you get 1 inch of precipitation and 30 inches of snow, that would be 3.3% density. Uh, Also, you hear about that at Bridger all the time with some of the home of the cold smoke up at Bridger Bowl with those really, really low density storms. So important to note, this is density, not snowpack percentages, just the density of the new layer or the entire snowpack on the ground. Okay, so snow courses, we measure them end of December through end of May, and they're applied to a monthly first of month reading. So January 1st through June 1st. At snow courses, we're using those tubes to measure snow water equivalent and snow depth, and then calculating density. There's typically either 5 to 10 sample points, and the number that gets reported into our database is just an average of all 5 or 10 points across that snow course. So it's like a transect through the forest, as you can see in this map. So we're just sampling at each one of those points and measured with the federal snow sampler, snow tubes. A picture of Old Faithful Snow Course from a few years ago. Old Faithful Snow Course, which is pretty close to the geyser, just kind of off that parking lot up in the park near the geyser. But that one was established in 1975. You'll see how many snow courses there are on the map here coming up in the next couple slides, but there's quite a few. We have a small staff here at our office. We can't measure them all ourselves. So it's a whole cooperative effort. So just some of the folks that help us collect snow data at snow courses across Montana and northern Wyoming. We have some very old snow courses in Montana. So this is just listing the oldest ones. Some of the ones up in Glacier Park, which are these 100-plus-year-old ones. It's only measured on May 1st up there, 102 years of observations. We only missed a couple measurements at those over all the years. One of them was COVID, couldn't travel, so missed measurement. And then there's some other missed ones. I'm not sure the reasons. But yeah, so Yellowstone Park, 21 mile, West Yellowstone, 87 years of record. So, okay, Snowtel sites. So Snowtels collect and report hourly data throughout the year. We're looking at that data pretty much daily during the winter and quality controlling the daily data. Daily data is what gets used in all of our tools and products, which we'll get into later. You can access hourly data for, recreation type stuff. Just be aware, hourly data. It's looked at, but it's not always edited and quality controlled. Snowtel sites measure snow water equivalent, snow depth, precipitation, both in the form of rain and snow, air temperature, and then we do have a handful of sites that measure those other metrics as well. Here is Slegamel Lake Snowtell in the Beaverhead Range, just kind of showing how it's laid out. So the snow pillow measures the snow water equivalent. It's just the weight of the snowpack building up and then putting pressure on a transducer in a shelter. So we're weighing it for the amount of water in the snowpack. Snow depth sensor shoots a signal down, flex back up so you can get the depth down to the snow surface and then subtract it off the zero from the summer. Air temp, RH, wind, precipitation. We put about 5 to 10 gallons, maybe a little bit more, certain sites of propylene glycol in there. So if it snows in the winter, it'll melt that propylene glycol, increase that fluid level. And then we're just measuring that fluid height, measuring the incremental precipitation accumulated throughout the entire season. Uh, all snowtails run off batteries and solar panels, and then they transmit via either satellite or cell technology. Same snowtail, just a picture of it in the winter. Fisher Creek Snowtail near Cook City, Montana. Just showing a picture of that one since that's more local. Here's a map of our networks. So New Mexico to Alaska. Snow courses are the lighter blue dots. Snowtail are the darker. And that's our numbers. Interactive map also includes stations in Canada. And then California Department of Water Resources has their own state-run snow survey network. Looking at Upper Yellowstone in particular. So we have 22 snowtail sites. Upper Yellowstone being this whole boundary. It's not above Livingston. It's everything down to right below where the Clark's Fork of the Yellowstone comes in. But I wanted to include some of these other stations in there, Boulder and Rock, there's Stillwater rivers. But yeah, so 22 snowtails, 13 snow courses ranging in elevation from 5,900 feet about to 9,400 feet. Parker Peak Snowtail right here is the highest in the Upper Yellowstone River Basin. Okay, so to access our data, a couple different ways. One method would be to go to the Montana Snow Survey homepage where you can find different links to current conditions. You can find program information, current conditions, Outlook reports, all that stuff on there. If you Google Montana Snow Survey, you will most likely you'll get to this link right here and be able to get to our Montana Snow Survey homepage. But honestly, the best place I believe to go is to this National Water Climate Center applications page. So NWCC apps with that link there. You can get that from our webpage, but you can also get to it and bookmark it. So what this has is just access to all of our tools, products, including site plots, basin plots, the interactive map, report generator, different reports, forecast, water supply forecast plots, so forth. And kind of the main focus I'm going to be hitting on here is the interactive map, but then also interactive map and then some of those basin-wide plots. So let's see here. Starting off with the interactive map, we got what you can find on an interactive map is snow water equivalent, current, historic, deltas, onsets, peaks, meltouts, and you can access all that by utilizing our control panel right here. I'm going to be the first to admit it's kind of a complicated tool. And if you're not spending a lot of time in it, you might get a little lost. But the good thing is you can just bookmark whatever you find in here and it'll bring you back to that same stuff time and time again. And we do have some bookmarks on our webpage, as I mentioned, that'll bring you right to those specific spots. But yeah, just a list of all the data we have on there. And as I mentioned earlier, it's not only NRCS data. We also have USGS, ACES, all the other agencies where we might be utilizing that for our water supply forecasts. Our most commonly utilized product is most likely Snowpack percentages. So the thing I wanted to point out here is we talked about snowtails and snow courses. So we have two different maps you can look at. monthly. So monthly includes snowtail and snow course, or daily. So this is most recent monthly measurements were end of January, but then daily we're mid-month. So I wanted to show you what the February 17th end of day data looked like. A little bit more on snowpack percentages. So if you're in the interactive map and you click on a basin or a site or station, it'll bring up more information. You get a little pop-up dialog box like this. And so you can click on the chart, the plot to get right into that, and that's dynamic, or you can expand stations. And the stations list right here. This is basically showing how like a snowpack percentage is calculated for this example, the Upper Yellowstone. So it's comparing the existing snowpack to a median value. So we use medians as a middle value because if there's any like big outlier years that would skew an average. So we're using medians for our snowpack percentages. The way that is calculated is it's all the sites. So we're summing the observations, the current snow water equivalent at all the sites, summing the median, and then you divide the two. So there's the sum and the sum, right to 101%. So if one of your higher elevation snow tells is got a big deficit, you'll see that in your overall percentage. Whereas if you just averaged all the percentages, it wouldn't be as much of a like weighted average in that case. And then as I mentioned, you can click on that dialog box to get to these plots. So a little overview of this, snow water equivalent on the vertical axis, date, horizontal, daily maximum. So that's this top blue line is not any given year. It's the daily maximum for each one of those dates. So that's why 1997, really big snow year, formed that maximum for most of the year, but it wasn't. This was probably 2011, if I had to guess, forming this portion of that maximum line. Daily minimum. This year is in black. So another way to look at that percentage is the value there divided by that median line in the middle, 102, which is slightly different just because of rounding, because we had all those individual values on that table compared to just a point here and a point here. That'd be the difference. And then you can turn on different years to compare them in this map. That's how I turned on 97. You'd click on it. And biggest point here is we're right about normal for our snowpack currently, but median peak SWE, which is this value, is just under 20 for the entire basin. So we still have if it stopped snowing right now, we definitely still have quite a bit of a deficit moving forward. So it needs to keep snowing. One thing I wanted to note about the median peak SWE is because the snowpack is peaking on different dates every year, like it reaches its highest value for that season, maybe right here one year, maybe over here another year. Since this is a median line for daily median, that high point is not a true median peak. So if you looked at the peak value, inches of snow water equivalent, and peak date separately, you could plot that as a point, and that's essentially what that is. So this is a little thing about percentages. I wanted a little shout out for caution while using snowpack percentages during certain times of the year. So 2024 is plotted on this map. You remember last year, I'm sure, very low snow year. It was riding that record low snowpack line, and give April 1st, May 1st, record low, near record low snowpack. But then come like early June, because we had late spring precipitation, kind of melted out slowly. We had about 100% of median snowpack on June 1st. So if you see that around June 1st, just be aware you need to look at the bigger picture, what happened throughout the season. In this case, it was really low. Stuff like this does help for overall runoff in the spring and the summer, but I'll show you on a map here. Okay, so this is in this table, chart, Yellowstone River at Billings, total volumetric stream flow for the Yellowstone River at Billings. So median in green, so April near normal, overall runoff, total volume of water to run through the river, May, it was cold, not a lot of runoff. So that's why it was below normal. That extra precipitation we got during May came off in June, helped a lot. But then July, because it was such a low snow year, was below normal runoff. August was slightly below normal. And then September of last fall, we got a ton of precipitation, which helped boost that back up a little bit. And just a little bit more on snowpack and medians. So this is Fisher Creek Snowtell again, 9,100 feet approximately near Cook City. Installed snow water equivalent was installed in 1967 with a recorder chart, automated probably in the mid 70s as a snowtell. Snow depth sensors were not available until about 99, so that's when it got its snow depth. So that's why there's not complete snow depth values here. But what I've done is I ranked snow water equivalent from lowest. So 2024, February 18th was the lowest snow water equivalent measured. Uh, and then the highest ever measured at that site, 1997, on February 8th. For the February daily reading, not the highest ever measured, just that date was 47. So it's just showing the general range of where we're at. So this year we're at 21.3, which is just slightly below average at that elevation currently. So more on snowpack and median. So this is still looking at Fisher Creek Snowtell site. So you might be thinking like there's so much snow in Livingston right now. It's outstanding. It's pretty amazing. But how are we only at like 100% of a snowpack in basin wide? It's just because of the higher elevations had such a deficit earlier in the year. So we're dealing with like this line, snow water equivalent building. You know, mid-December we started getting some snow, dry, more snow early February. So we've been kind of playing catch up with this deficit experienced earlier in the year. So current SWE 21.3 at that site, median SWE 24.5. Still a ways to go to get to that median peak, and current deficit 3.2. So knowing like that area, I mean, a couple big storms, we could make that up pretty quick, hopefully, as long as it keeps snowing. All right, just another way to look at those deficits on our interactive map. You can grab snow water equivalent in the element, and then if you go to anomaly, and then it'll say POR for period of record by default. But if you want to look at the median value for the typical median data set, you do your data display options fixed 91 to 2020, click that instead of period of record, and it'll populate like that. So there's that 3.2 we're seeing at Fisher Creek. You know, some places like the Bridgers actually have a little bit more than normal. Same with some sites in the Crazies, Shower Falls, south of Bozeman, pretty significant surplus of above median snowpack. So it's not all about the snowpack. Water year precipitation is also important. That's available on the interactive map as well. So we're about 96% in the upper Yellowstone currently. We collect our precipitation in these Snowtell gauges, both solid and liquid, as I mentioned earlier. The other nice thing about looking at precipitation is you're also gathering valley weather station information. Some valley weather stations provide solid precipitation as well, but mainly it's just rain. Like if it's a tipping bucket, it's most likely just rain, unless it's a heated tipping bucket, which takes a lot of power to run. But yeah, so just another thing to look at, another resource if you're trying to figure out how we're doing for the year. And I just these charts are available for precipitation accumulation as well. So this is Upper Yellowstone, looking at that 2024 again. So big start to the year. It wasn't snowing really much, but we actually had a well above normal early start to the year. And then it was dry conditions throughout the year. But there's that September bump that I was talking about earlier in Upper Yellowstone that really helped the river levels a little bit. So that's a lot of information. So for anyone to parse out, like even for myself, like I really have to sit down and think about this stuff to kind of figure out what's going on. So what we do helps both ourselves and hopefully the general public is write water supply outlook reports monthly, January through June. So we're just summarizing precipitation data, snowpack data, temperature data, all those values there, looking at future outlooks and our water supply forecasts are in there as well. I didn't really hit on the water supply forecasts for this because it's pretty in depth, another topic. But basically, total volume of water for any USGS stream gauging station based off snowpack precipitation, forecasting that total volume for extended time periods. One example would be like May 1st through September, what's the total volume of water? So that information would be contained within our water supply forecasts. And then major basin overviews as well. So just a little bit more on specific conditions. In terms of recreation, so also beneficial use of the SNOTEL program. How much snow is out there? How much new snow is out there? On the interactive map, you can go to station conditions, snow water equivalent, delta, look at the value. Looks like I got the value on there twice. Same shot there, value. And then you're going delta 5 days. You can change your period there. So this is basically showing us Bracket Creek, SNOTEL, for example, 5 day SWE delta. And if you use your density to estimate total snowfall, it would be about, say, 10% density. You'd get about 32 inches of total increased or total snowfall. The thing about snow depth at SNOTEL sites is because of the depth sensor is measuring down to the top surface of the snowpack, that snowpack is always settling beneath the new snow. So that top level is going down. So you might not get that full accurate depth increase on there. So that's why it only measured, if you looked at the snow depth delta, it was only 24. But if I had to estimate, it would be closer to 32. Or if it was really low density snow, maybe even more than that. And then looking at hourly data. So Bracket Creek again, click on the station itself within the interactive map. And then this pop-up shows up. Look at data reports, 7 day hourly. You get a table like this and you can sort it based off date and time. Bookmark these. I have even on my phone, I have a bunch of these bookmarked so I can kind of go to my favorite sites and see where it snowed the most. And then last couple slides here, other snowpack resources. So National Operational Hydrologic Remote Sensing Center. This data only goes back to 2002, I believe, give or take a year. And it's remote sensed, it's modeled, estimated data. It is somewhat calibrated off SNOTEL sites. We talk to these folks every once in a while. And, just to make sure like this site matches what their inches of water equivalent is showing. But you can see more valley conditions because this program is more specifically mountain snowpack. And then the Montana Climate Office has their amazing drought dashboard. If you haven't seen that, you should definitely check it out. They actually use that SNODAS data that I was showing in that last slide to populate their own basin percentages. So you can include some valley related stuff, so showing elevation and how that compares to the gray bar there for median values, percent of average, and so forth. So just some other resources to look at. And I think with that, yeah, got some time for some questions.
Thank you, Eric. Yeah, so let's open it up. Anyone
Welcome.
has any questions, feel free to come off mute and ask them, or you can type them into the chat window as well.
I have a question. This is Wendy Riley. Hi, Eric. Thanks for coming on. I'm on the PCEC board, and I was just on SNOTEL yesterday in kind of trying to figure stuff out in advance of today. and looking at the Upper Yellowstone watershed area in particular, and saw that there, and I was looking at the view that you had of just a few slides ago that has the little dots showing like light blue, dark blue, and heavy snow, and yellow, orange, red, not, or below average. Anyway, what was curious to me is that I saw like two dots that were seemingly close together, where one showed above average, like it was light blue, and the other dot was yellow. And they couldn't have been more than, I don't know, 20 miles apart. I'm just guessing, 10 maybe. And I'm curious about if it has to do with, well, what does it have to do with? I mean, I've hypothesized a few things. How would you explain that?
Yeah, I would explain it probably if I'm not sure which exact points you're talking about, but this one might help a little bit. It's probably elevation based, like
Yeah.
so like even right here, like in Cook City, so Fisher Creek Snowtell this time of the year has a significantly deeper snowpack than the really low elevation northeast entrance Snowtell. So because
Okay.
there was such a huge, yeah, does that make sense?
Yes. So I could see the change from yellow to green. That's kind of close. But what I was seeing is like yellow to light blue. And that was yesterday.
Okay.
And
Yeah, I guess if I had to guess, like I said, it's probably elevational based.
okay.
There are different, weather patterns that affect different sites differently as well, and that's why we kind of station them and locate them in different spots because you might be getting different orographics or different things going on. Even if it was same elevation, somewhat close, it might be just due to just what type of weather favors that site.
And do you typically have the sites at a certain elevation and above, or do you have sites also in valleys and lower elevations?
Yeah. They're generally for this program, we're measuring just like mountain elevations and above. So some of our lower elevation stations, Burnt Mountain Snowtell right here. It's one of the lower ones. What I think I said that earlier, it was like 5,000-ish some feet up to like just below 10,000 feet for like Parker Peak Snowtell right there. So yeah, we're kind of covering that mountain snowpack range. We're not focused as much on the valleys because, well, there can be a significant amount of snow in the valleys. Like even right now in Livingston, there's probably, I don't know, if I just bring some snow tubes home and measure it, but maybe 6 inches of water. You compare that to like Peak Sui in the mountains is like 40 to 50 inches of water. So like even the bulk of that water is coming from the mountains. That
Yeah.
valley component does play a big role, but it's not as important, I would say, on a normal year.
Thank you.
You're welcome.
Yeah, Eric, Colette has a question. She's curious to know where 21 Mile Snow Course is in Yellowstone.
Yeah, it's on the section. That's not showing it because that's daily data right here. I have a monthly data. It's on the section in between, when you head north out of West Yellowstone, uh, and you're going towards Big Sky. It's on that section where you like are back in the park for a little ways, right by like kind of the trailheads for like Fawn Pass, Gallatin Lake, that type of stuff. It's just off to the right below oh gosh, the ski area up there that everyone's skiing. Telemark Meadows and Bacon Rind, kind of between those two spots.
It's like John Mills
Yeah,
has a question.
thank you, Eric. Thanks a lot for this. I'm very naive about it, and I learned a lot. This may not be in your wheelhouse, but in the Park County growth policy, and I'm going to read it. Park County does not have the scientific understanding of its water resources, Park County should strive to establish a scientific baseline of water resources, including ground and surface water, in preparation for decision-making. That was a 2017 growth policy. Has anything been done to coordinate your data and the other data sources out there so that a plan can be made? Because later on, it says water is critical to development.
Love that question. Yeah, thank you, John. Yeah, so later on in this series, John Lunzer is presenting on a lot of that stuff, groundwater related topic. Max probably has more information about that. But yeah, there's the whole mesonet stuff going on in the valleys. Just we do talk with these other groups, collaborate and kind of decide where we're putting stations and stuff. But yeah, it's there. The more networking, the better related to that stuff and communication. I don't know if it really answered your question, but yes, there is
Yeah.
some partnership going on there.
And I can
Mhm.
just add to that, John.
Yeah.
There has been a lot of work done since the 2017 growth policy was published. And like Eric has mentioned, John Lunzener is a hydrologist with the Department of Natural Resources and Conservation. He's just completing a water balance of the Upper Yellowstone. So he's been taking measurements of all the inputs and outputs in the system to give us an idea of how much water comes in and how much water is being used. He's going to present on that in the fourth part of this community conversation series in May. So stay tuned for that. And then, yes, as part of the Upper Yellowstone Watershed Group's Drought Advisory Committee, we've also installed what Eric mentioned, mesonet stations, which are monitoring precipitation and soil moisture and everything throughout the valley floors. And it's especially important, kind of during the growing season for local producers, but also tracking drought conditions. So a lot of good work has been done, especially through the watershed group, to move that forward. So we're in a much better shape with data than we were in 2017.
Thank you.
Max, this is John Heike. I just want to add a note to that tomorrow night's Park County Planning Board meeting, there are presentations on migration of the stream of the Yellowstone and some other things in terms of groundwater. So water's on the agenda, if not snowpack.
Yeah, great. Yeah, I bet there'll be some snow discussions. And then on that note, that channel migration zone map update that you're referring to, Jeanette Blank with Montana Freshwater Partners is going to be presenting on that as the third speaker in this series this spring in April. She will be joining us to present on that as well. So there's multiple opportunities for people to hear about that mapping update, and that's important because that's where the water's going when it's running off. And it'll that mapping helps us see where the channels of the Yellowstone trying to move or have moved or could move in the future with another flooding event.
Eric, I've got a question for you. I've always wondered why right now we're using the 1991 to 2020 median as like the benchmark. Up until 2020, it was like the 1980 to 2010 benchmark. Like, why does that keep moving? And, theoretically or in the face of long-term declines in snowpack, I've always kind of wondered why that seems to be like a moving needle or a moving baseline to be comparing to.
It's like a standard set by the worldwide organization, I guess, for just like the change in climate, for whatever the reason, is just trying to match that so you have a tighter data set to compare it to. I guess I don't really have the best answer in it. I have heard some folks say recently they kind of wish it was more of like a 10-year moving average or median. But it's just to kind of match, just any changes within recent weather and climate, essentially. Yeah.
Cool. Thanks. You should come play soccer again, by the way. Where you been?
Maybe tonight.
Well, we're coming up on the hour. If anyone has one last question they'd like to throw in there, go right ahead. Otherwise, I'd say we could wrap it up so people can get on with their day. I'll hold for a second. Well, great. Thank you, Eric, for joining us today and presenting on this and sharing your scientific skills and your knowledge. It's been very helpful, very informative. I really appreciate it. And thank you everyone for joining us and listening in on this presentation as well. I hope you all have a great day and stay warm and don't get stuck in the snow.
Thank you.
Thanks, everyone.